Question number 5. A particle is projected horizontally towards a vertical wall 1.5 meter away. It hits the wall 1 meter below the initial horizontal level, as shown in the diagram. You are asked to find A. The time of flight, B. The initial speed of the particle. First, let the time of flight be t, and let the initial speed be u. In the diagram, the initial speed u, okay? This is u. First, let's look at its vertical motion. Since the particle is projected horizontally, therefore, we have uy, initial speed along the y-axis equal to 0. Using the equation of motion, we have y equal to uyt plus half gt squared. Uy is 0, therefore y equal to half gt squared. Substitute the value of y equal to 1, therefore y equal to half gt squared becomes 1 equal to half g is 9.81 times t squared. We have t squared equal to 0.204. Therefore, t equal to 0.45 seconds. The time of flight is 0.45 seconds. Let's consider its horizontal motion. That is the motion along the x-axis. Okay? For a projectile motion, the horizontal speed Vx is a constant, which is equal to the initial horizontal speed ux. In this example, since the body is initially projected with a speed horizontally, therefore we let u be the horizontal speed. Okay? As a result, Vx equal to u. The horizontal displacement x equal to the constant horizontal speed Vx times the time t. Now we have x equal to 1.5 meter, and Vx is the unknown. We need to find it out. Time t, it has already been found, equal to 0.45 seconds. Therefore, Vx equal to 3.33 meter per second. Hence, the initial speed is equal to 3.33 meter per second. Question number 6. An object is thrown horizontally towards a vertical wall 1.2 meter away. It hits the wall 0.8 meter below its initial horizontal level. Just before it hits the wall, find its vertical speed, find its horizontal speed, and find the angle that the object makes with the vertical. Let's first consider its vertical motion. That is the vertical motion. Consider the vertical motion first. Maybe this is axis, we call it y. We have uy equal to 0 since it is initially projected horizontally. Therefore, there is no initial vertical speed. Then uy equal to 0. Using the equation, y equal to uyt plus half gt squared, because it's falling freely, its vertical motion is a free-fall motion. We have y equal to 0.8 equal to half 9.81 t squared. Therefore, we find t equal to 0.404 seconds. Just before it hits the wall, we let the vertical speed to be Vy and the horizontal speed to be Vx. Consider its vertical motion. We have Vy equal to Uy plus Gt. Vy equal to 0 plus 9.81 times 0.404, which is equal to 3.96 meter per second. This is the result for part A. Next, let's consider its horizontal motion. The horizontal distance traveled, x equal to horizontal speed Vx times time t. In the diagram, we have x equal to 1.2 meter. Therefore, x equal to Vx times time t. T is 0.404 seconds. Therefore, Vx equal to 2.97 meter per second. This is the answer for part B. Let the angle that the object makes with the vertical line to be theta. Okay, this vector is v, which is the resultant velocity. From this part, we have tangent theta equal to Vx over Vy. Okay, which is equal to 2.97 over 3.96. Therefore, theta can be found to be 36.7 degrees. And this is the answer for part C. Question number 7. A tennis ball is struck horizontally by a racket at A at a height of 1.25 meters above the ground. The ball hits the ground and rebounds so that it just goes over an obstacle C at the highest point of its path. During its impact with the ground, the vertical component, the vertical component of the ball's velocity is reduced by 30%. Assume the ground is smooth and you get air resistance. Part A, find the time of flight, let it be t, and of the ball from A to B. Hence, find the horizontal and vertical component of the ball's velocity at B just before impact. We let the horizontal speed just before impact to be Vx. We let the vertical component of the ball's velocity at B just before impact to be Vy. Okay. Part B, find the speed of the ball at B just after impact. To find the time of flight t from A to B, we use the vertical motion. Okay. We have applied the equation y equal to uy t plus half gt squared. 1.25 equal to 0 because uy is 0 plus half 9.81 t squared. Therefore, time of flight from A to B equal to 0.505 seconds. Just before impact, the vertical velocity is Vy Vy can be found by using Vy equal to Uy plus Gt equal to 0 plus 9.81 times 0.505, which is equal to 4.95 meter per second. Consider its horizontal motion along AB. Let the horizontal component of the ball's velocity at B to be Vx, which is equal to the initial horizontal speed u. Consider the horizontal motion along AB. We have x equal to Vx times t, and x is equal to 3.5, therefore 3.5 meters equal to Vx time is again 0.505 seconds. Therefore, Vx, the horizontal speed just before impact, is 6.93 meter per second. Since we assume the ground is smooth, which means that the velocity of the ball, the horizontal component of the velocity of the ball just before impact and just after impact at B are the same. That means just after impact, the horizontal speed we have Vx pi is also equal to the horizontal speed just before impact because the ground is smooth. Therefore, we have Vx pi equal to Vx equal to 6.93 meter per second. However, you are given that during the impact with the ground, the vertical component of the ball's velocity reduced by 30%. Therefore, after the impact at B, the vertical velocity of the ball Vy pi would be Vy pi equal to 70% of the initial velocity, vertical velocity during impact, which is Vy, which is equal to 0.7 times Vy is 4.95, which is equal to 3.465 meter per second. Hence, for part B, the speed of the ball at B just after impact is V equal to square root of Vx pi square plus Vy pi square, which is equal to square root of the square of 6.93 plus the square of 3.4565. Therefore, V, or the speed of the ball at B just after impact, is equal to 7.75 meter per second. In this question, we also assume that there is no air resistance, which means that the acceleration due to free falling is equal to g.